Geometry, properties of parallelogram. So we'll be studying the properties of parallelogram on this particular lesson, 9.1. So we need to first start with the definition of quadrilateral, right? Quadrilateral is a polygon with four sides. Quad is a four, lateral is side. So using that definition, right, parallelogram is a quadrilateral four-sided figure that has two pairs of parallel sides. They have two pairs of parallel sides, right? All right, let's begin. Continue on over here, guys, okay? So we're going to be proving the opposite sides of the parallelogram are congruent. So here's the theorem, guys. If a quadrilateral is a parallelogram, then the opposite sides are congruent, right? And sometimes if you want to write that in terms of just a picture. You could just draw a parallelogram like this, implies that opposite sides are congruent. You could just draw a picture, all right, if you so wish. Okay, so here's the guided proof that we have. We first start with, as usual, the given information, and this is what we're trying to prove. So we know that the ABCD is a given figure is a parallelogram, so we know that the both pair of the opposite sides are congruent, right? Sorry, are parallel. So that's the given information here, that parallel like this, right? And then we're supposed to prove that the AB and CD are congruent, and then AD and CB are congruent. How do you suppose we could do that? Here's a hint for you guys. Because this is parallel, the first thing that should come to your mind is this N shape or Z shape, and then alternate interior angle. Right, guys? All right, guys. Why don't you guys go ahead and try this on your own? Okay, so we're back. So here is what you should have done. First of all, as it was implied, what you should have done is to draw a auxiliary line right there, right? You're allowed to do that because through any 2 points, there's exactly one line. And that was a given information right there. And we know that the AB and DC are parallel and AD and BC are parallel because of the definition of parallelogram. And we know that these two angles right here, right, are congruent, and these two as well, right? Because the alternate interior angle theorem, well, what you could have said is that the two parallel lines cut by a transversal is cut by transversal, then the alternate interior angles are congruent. Or you could just write that out this way. And we also know that DB is congruent to BD or DB in this case. And that's a reflexive property. And these two triangles are congruent because of angle side angle triangle congruence theorem. And we know that AB, see that AB, first and the last, is congruent to first and the last CD. And AD here is the first two, is congruent to the first two CB. That's by CPCTC, right? Uh, that stands for corresponding parts of congruent triangles are congruent, right? So this part is congruent, that part is this, okay? Okay, guys, and that was it. All right, guys. All right. How about next one? We are going to try to prove that the opposite angles are congruent. Right. So the theorem says if a quadrilateral is a parallelogram, then the angle opposite or opposite angles are, the word is congruent. So we have something similar going on over here, guys. And let's take a look. Okay. All right, guys. Um, yeah, so because this is a guided proof, I'll let you work on this on your own, right? And while you're at it, um, prove that the diagonals bisect each other. And if a quadrilateral is parallelogram, then the diagonals bisect each other. My suggestion to you there is the following. Draw a picture like this, right? A, B, C, D, right? And draw a 2 right there. 2 diagonals. And you may use the information from the above. So we know that these two are parallel, and we know these two are congruent, right? And what else can you tell, right? Right, alternating angles. And I think you have all the tools you have necessary to be able to do this proof. Okay, guys? All right, guys. So why don't you stop the video and work on the problem? Okay, guys, I think we are ready to go over the stuff. Right. For this one, to show that the opposite angles are congruent, it's essentially very similar to what we did earlier, right? When we try to show that the opposite sides are congruent. So essentially what we did was that's a given information through 2 points. There exists exactly one line. And we know this is true because definition of parallelogram. So these first 3 steps were exactly the same. And we just added these two to show that these 2 angles and these 2 angles are congruent because of the alternating triangle theorem. And we also know that DB is congruent to DB. When we do that, what we end up with is this triangle is congruent to this triangle by angle side angle triangle congruence theorem. And we know that the angle A and C are congruent, right? So we know that the opposite angles of a uh, parallelogram are indeed congruent. Now, if you really wanted to, you could do the same exact proof all over again, this time drawing a diagonal through AC, and the rest of the proof will be exactly the same. Okay. Now, let's take a look at this right here, guys. So I forgot to put this shape right here, and that is A, B, C, D. All right. So as long as we can show that these two are congruent and these two are congruent, we're good, right? So the ABCD parallelogram is given to us, and we know that the ABCD is congruent to each other and parallel, right? So A, B, and CD are congruent and parallel because the opposite sides of triangles are congruent and parallel. We have already learned that, right? And we're going to draw DB and AC, DB and AC right there, guys, right? So there you go. Through the 2 points, the reason is because through 2 points, there's exactly one line or one line segment, right? Note that segment is a part of a line, so that is perfectly legitimate way of saying this. And by alternating triangle theorem, BAM is congruent to DCM. So BAM right there is congruent to DCM. See that? And then BM, this right here, is congruent to this angle, CDM, right? So we know that this is the same, this is the same, this is the same, to this is the same. And we know that by side angle congruence triangle theorem, these 2 triangles are congruent. So we know that AM is congruent to, see that right there, is CM, and DM is congruent to BM by CPCTC. Hence, the diagonal of a parallelogram bisect each other. Looks good, guys? All right. Okay, so let's look at the next one. Here it is. Here's the theorem that we have. So now we have a parallelogram. In this particular case, we're asked to find CD, right? So yeah, you should do that, right? And how could you do that? Because the opposite sides are congruent. And also, given the fact that ABCD is a parallelogram, find the angle B and side BC. Okay, take a few minutes to do this, guys. Please stop the video and work on the problem. Okay, guys, I'm going to assume that you have done so. So here goes. So in this particular case, I really need you to state the reason why you do this in the first place. We know that the A, B, and C, D are congruent because the opposite sides of parallelogram are congruent, or by extension, equal to each other. So we know that the 5y minus 4 is equal to 2y plus 8. Solving for that, y turns out to be 4, but we're not done. We're not looking for y. We're looking for length of the segment CD right there, right? So CD is equal to, by definition, 2y plus 8, but y is equal to 4. So putting that in, CD is equal to 16. All right, guys, let's look at the next question. To find the angle B, we know that the opposite angles, this one and this one, are congruent. Angle C and angle D and B are congruent because the opposite angles are congruent. And if they're congruent, they have equal measure. So you could set the values of each equal to each other, which we did. Solving for that, x is 14. But once again, we're not solving for x. We're solving for angle B. And B, by definition, is 9x minus 4, 5, and x is 14. Plugging all the values in, it comes out to 121. And to find the BC, we set these two equal to each other because the opposite sides of parallelograms are congruent, or by extension, they equal to each other. And then we got y squared minus 4 is equal to 6y minus 7. Putting all that into one side of the equation, we get that. By factoring, we have this 9y minus 5 times y minus 1. And setting individual expression equal to 0 by property of 0. Okay, let me write that down. We go from here to here because of property of 0, right? Because when two things multiply to each other is equal to 0, one or both are equal to 0. So y could be either 1 or 5. Once again, we're not done. We're not looking for y. We're looking for BC. Now, if y is negative, that's not necessarily a bad thing, okay? We just have to make sure that the BC, which is the length of a side of a parallelogram, that has to be positive, okay? So when y is equal to 1, I plug that value into BC, and when it did, it was negative 1. No, BC has to be positive, so that's not an answer, okay? And the y could be 5, so I plugged it into the value of 5, that came out to 23, so this is an acceptable answer, so BC is equal to 23. All right, guys? All right, guys. So here's your turn. Why don't you go ahead and work on that right now? Okay, guys, I'm going to assume that you finished working on it. And the answer to that is this. And here are the steps. And if we have a question on this one, we will continue in the class. All right. All right, guys, I'll see you in the next video. Bye-bye.